Good morning to one and all. This morning I'm going to be talking about sustainable development, SAF, sustainable aviation fuel. So let's get started. Perhaps we can start with an equation that we're going to be building with my presentation. So we can start with CO2 standing for greenhouse gas emissions in the aviation field. CO2 equals CO2, everything's okay. All right, we divide that by energy, we multiply by energy. Energy for the airline transportation business is the fuel to get the planes off the ground. So that's kerosene, isn't it? Then you divide by traffic, you multiply by traffic. Traffic is the number of passengers per kilometre, the tons of freight that we're transporting in the bellies of our aircraft. And this gives us the Kaya equation. So CO2 emissions equal to carbon intensity, in other words, the amount of CO2 produced by energy, the CO2 that's emitted by the kerosene in the bellies of our aircraft, multiplied by energy intensity, the quantity of energy that's required to transport a passenger through a kilometre, multiplied by the traffic. So when we try and follow that Kaya equation and look at it over the last 50 years, well, why 50 years? Well, 50 years ago, that was really the beginning of the increase in aircraft traffic. 747-200, I think that was in 1972. Charles de Gaulle, 73, that was the oil crisis as well. And when you put that equation over the last 50 years, we have these four lines, and we'll look at those in greater detail in a moment. So the first is energy intensity, the energy required to transport an individual in the air. This has been cut by 5 over the last 50 years, as we see. How have we got then to that amazing efficiency level with more effective, more efficient, lighter aircraft, more aerodynamic, with engines that are bigger, that consume less fuel, more dense, in other words, with more passengers on board, which has enabled us, in a word, to improve technologically things to cut energy intensity by a factor of 5. Running alongside airline traffic, well, has been multiplied by 16. In other words, the number of passengers. So we've cut by 5 the energy intensity. If then we multiply the number of passengers by 13, then we have a massive increase of CO2 emissions, which have increased threefold pretty much between 1976 and today. Now, you would have spotted here, there is a curve we haven't made much of yet, and that's carbon intensity. So that's the energy. In other words, the amount of CO2 which is emitted by the volume of energy deployed. Now, for aviation, energy remains constant, kerosene, and we know that 1 ton of kerosene which is consumed in our aircraft emits 2 tons of CO2. So this hasn't changed for the last 50 years. That's a hard-nosed fact. And if we want to go bigger and further in decarbonation in the airline industry, it's the carbon intensity that we need to address. And to do that, we need to reach new fuels that emit less CO2. Obviously, this leads us to SAF. So, in respect of that, 4 figures here to put some numbers on the impact of aviation on the climate. 2.6% is the share of airline aviation's emissions in producing the world. So that's not a majority figure, of course, but it's still important and need to address. Now, these emissions, as we've seen, are on the up, and that significantly. And if the airline industry does absolutely nothing compared with other industries that are becoming increasingly decarbonized, then this level of emissions could reach 20% between now and 2050. Now, in my presentation, we're talking a lot about CO2 emissions, but it's not the sole aviation impact on the environment or the climate. There are also non-CO2 emissions, as they're called. In part, these are white smoke that come out of the airline engines and that persist for a while in the skies. So this trail has a heating effect, which is by no means negligible, and there are studies that are trying to properly appraise the non-CO2 impacts and to try and understand how we can reduce them. Now, this non-CO2 impact is pretty much on a par with CO2 impact, which means that aviation impact of 5% from the human-based aviation-produced effects on the environment. Now, if we look at airline traffic for one passenger, let's say, New York, Paris, 1 ton of CO2 emitted, bearing in mind that the average emission for one French person is 8 tons. So that's 10% of the average budget of your average Frenchman. And we see more and more passengers who are mindful of environmental effects. They worry about it, and the share of aviation, therefore, weighs heavily in this equation. For us, as a company, decarboning is now an obligation. It's not an option. We need to get from A to B, and so we need to set ourselves objectives that are bold. So what are they? Between now and 2030, from a CO2 perspective, we want to reduce by 30% our CO2 emissions in 2030 as opposed to 2019. So 2019 is the benchmark. Why? Well, it was the last year before COVID, where we had a kind of a nominal conditions in the aviation sector. So we want to have a 10% of sustainable aviation fuel operating on our aircraft between now and 2030. Now, if we want to have that decarbonation progress for the company, and we want to put it on a graph here, here we see emissions linked to the kerosene in our aircraft. This is what 99% of our direct emissions. So for the company, if we're benchmarking with 2019, like 20 million tons of CO2 emitted, here we can see COVID here, the blip, and then it goes up gently. At the top of the line here, this is theoretical. If the group does nothing, doesn't buy SAF fuel, doesn't renew its fleet, so we can see that CO2 would be on the up. Now, there are a number of levers that can be pulled to reduce those emissions. First, renewing the fleet. We can cut half CO2 emissions with some of our aircraft being renewed. Often the question is put, an electrical plane, hydrogen plane, could that be involved in renewing the fleet, have a sizable impact? Now, electric batteries are heavy, and they're really for smaller sized transportation vehicles with fewer passengers. Hydrogen, at best, we'll see that between 2035 and 2040. Those will be for short and medium haul because of the size of hydrogen tanks. Now, looking at 80% of our emissions really are long haul. So this type of aircraft, hydrogen-based, between now and 2050, won't have a significant impact on reducing our CO2 emissions. Second major category, operational measures. Now, here we're going to be talking about co-piloting, for example. So this would involve using one single engine when you're on the ground. When you're parked, you're going to hook up with electrics. You could also have reducing weight, on-board weight. And all those added up, you can get 5% savings, let's say, or reduction. And then we have SAF. Now, we think 70% SAF in 2050 equates to about a half of the overall efforts that the company must do to reach its objective, to reach carbon neutrality in 2050. So to reach that neutrality point, as we see here, we need to reduce carbon emissions. Human impacts will produce residual emissions. So to reach this 2050 neutrality, we need to invest. And we think about carbon sinks, for example, and there's artificial capturing, sequestering of carbon, or possibly even burying it. Now, what about SAFs then? There are two major categories here. Daniel will provide greater clarity on this in just a moment. But we talk about biofuels. That's biomass, that's plant-based, as it were. Lots of household oils, cooking oils, farming and forest waste in the future. Here, the plant captures CO2 in the air, in the atmosphere. That plant then is used to produce the SAF. That fuel will be consumed in our aircraft, and then it'll emit CO2, which once again captured by the plant. So in a closed loop. Same thing for e-fuels. We're going to capture CO2 in the atmosphere. We're going to combine that CO2 with green hydrogen, which will be manufactured, reproduced from renewable electricity. And then we'll have the same loop, the same closed circuit. Now, these e-fuels, when you look at the overall life cycle of them, we can reduce to the tune of 75% our CO2 emissions. So what's the salient feature of these SAF? Well, first and foremost, very strict environmental criteria. A company will want to be using SAF that doesn't compete with food-based fuels. There won't be any dedicated crops for this. No, we want to use waste, household waste, farming waste, or forest waste. And all our SAFs will be certified by independent bodies. Second important point, this is the drop-in fuel. We can mix it with current kerosene that's currently used, and we can have a 50% mix, which means that ultimately we don't have to invest in new aircraft, such as hydrogen aircraft or electricity-driven aircraft.
There are two major disadvantages to SAFs. The first one, it says very little production. It's estimated that in 22 there was 250 million tons produced of SAF, which is 0.01% of the totality of a fuel used in aviation in 2022. Very, very low. And the second point is that this SAF is very expensive today. It costs between 4, 5, 6, 8 times, up to 8 times the cost of classic fossil-based kerosene. So the differences may be linked to the types of technologies used. And then maybe a few words with regard to the SAF strategy of Air France-KLM. Ben Smith told us, Air France-KLM, he reminded us, they're trailblazers with regard to the use of SAF. With the first commercial flights with SAF date back to 2011. And in 2022, with just over 40,000 tons of SAF, as Ben Smith said, we took 17% of worldwide SAF produced, and we had this ambitious objective to attain 10% SAF by 2030. So how are we going to get there? How are we going to get there? We've already started to implement commitments over the long term. Air France-KLM has committed to buy 1.8 million metric tons of SAF between 2023 and 2036 with big European and American companies. We also have implemented many partnerships with companies which are French, Dutch, international, to ensure that between now and 2030, we attain our objectives, the 10%. And we've said this, but this cost of SAF with regard to the fuel cost, which represents between 20 and 30% of the cost of an air flight company, means that there's a new economic equation in place with an impact on the cost of a ticket. In 22, where we've already started to increase the price of flights out of France and the Netherlands by a few euros. It's also an investment which is done by our customers who individually can purchase SAF for when they book. And Air France and KLM have also implemented a program for the corporate customers, whether that be a freight or passenger, to decarbonate their activity. They can invest in the purchase of these SAFs. So that brings us to the end of the overview, the first general overview. I've wanted to show you the position of SAF in the industry and in Air France strategy. And now I will give the floor to Daniel Iracane. Thank you, Antoine. Hello, everybody. Indeed, the Academy of Technology published last March, very recently, a report on decarbonization of the aviation. So, although we're not specialized in aviation, we thought it would be really iconic, which is of the decarbonization of the society as a whole. So we looked at the aviation industry like an example of the challenges which lie ahead for society as a whole. So the first comment is what we wanted to do. What did we want to do in this report? We wanted to see whether a physical trajectory exists. Is it possible, first and foremost, to really get to decarbonize the whole industry in the sense that Antoine talked about, once you've taken into account all the efforts with regard to the aviation technologies, and we're going to come back to the needs. So what we looked at is, yes, it can be attained with considerable efforts, but one point that needs to be highlighted is that those efforts are comparable to the society's current effort that they need to do with all its activities. There's no just aviation syndrome. It's a topic which is absolutely iconic and of the challenge that exists for the whole society. And that's where we thought it would be really interesting to go into detail. So technically, what we wanted to do, we wanted to compare the needs, the technological possibilities, and where is the energy going to come from? Where's the energy which is going to enable us to produce these different types of fuels? The first point is that we need to take into account the technological and technical advancements, as has been said, and then we see what the residual demands are. Then we not go into many figures today. Although you have figures on the slides, you see the two which circled there. It shows that once the quantities looked at are gigantic. If France, it's 2 million tons by 2035, 10 by 2035, and 30 by 2050. So that's calibrated on the 2 million in 2035 for France. And there's a second important message on this table. It's the acceleration, the brutal acceleration of these commitments that they will require and demand. And that has a major consequence. The Academy of Technologies is not specialized in the aviation industry, and we were not looking at whether traffic is going to increase, decrease. We looked at the references which exist, and the acceleration is so strong, so massive, that even if traffic is not what is anticipated, forecast, so there are efforts made around sobriety or economic constraints or geopolitical constraints, which mean that the traffic levels will decrease or increase as opposed to what is estimated there. It will change nothing to the presentation and to the message that I'm imparting today, because we are on a steep curve. Whatever occurs, things may change. But the efforts that are required to initiate these technologies are the same. So even if it's 6 million in SAF by 2050, we're at 5 million or 7 million, that would change nothing with regard to what needs to be undertaken here, now, today, to prepare for this trajectory. So this looks very complicated, this slide, so I won't go into detail with the figures. We'll focus on what is on red here. So what is at play? We need to, at stake, we need to produce sustainable fuels. Antoine has said it, but I'll repeat it. It's a fuel which is totally, can be mixed with the current kerosene, and which is going to burn in the same way and produce the same quantities of CO2. So what is the trick here is that we're going to remove the carbon from the environment, and it's not fossil-based carbon, because that is what we're talking about. We're going to look for carbon which is within our environment and not use fossil fuel. And we need to not add the carbon into the air, because the carbon emitted during the flight has been taken out of the environment such as it exists today. The most simple way of doing that is going towards biomass solutions. Why? Because if you look at the composition, it's carbon, hydrogen, oxygen. We don't need oxygen, we can remove that, but we are going to really work on the hydrogen and the carbon of the biomass. Two major approaches here. We've heard a lot that biomass is going to solve a lot of issues of decarbonation for the society as a whole, but there are limits. Those limits are what biomass is in competition. There is a competition. There's a lot of industries looking to use biomass with functions which are major functions, such as the food, producing food, diversity, biodiversity, and in different economic sectors. So biomass is limited from a quantity point of view. And we're going to solve partially this issue. How? By adding hydrogen to biomass. So what's the idea there? It might be a new idea for a lot of you. In biomass, on average, you have these fuel that you put in your cars, like the one you put in planes, there's 4 hydrogen for 2 carbons. So biomass, there's a deficit of hydrogen. If you use it such as it is, that is the middle line of the slide here, it's feasible, but then you're not using biomass in the best possible way. And there's a lot of competition for its usage. So if you're not using it well, that's a very bad idea. There's not enough biomass from the start. So you really need to optimize the way in which it is used. So to use this biomass in the best way possible, you're going to add hydrogen. It's the top that you see there, and it's what we call e-biosaf. Bio, why? Because we're valorizing the carbon and hydrogen present, and the small e, it's because we're going to add a lot of electricity to produce the hydrogen, which will re-establish the right balance between carbon and hydrogen, which is necessary for the fuels. Once we've done that, you multiply by 2 the yield of the biomass production. So it's good. It's more complicated, and it will take more time to implement, to put in place, because it is more complex, but it will need to be done. But once that is done, even by increasing the yield of biomass by 2, there'll still be the limit of biomass. There is not sufficient biomass to decarbonize all society, feed the populations, and so on. There are limits. We'll come back to those figures shortly. Once we've attained to that limit, we need to continue our trajectory of decarbonation, because we don't have the choice, and the solution is to take the carbon where there's a lot of carbon, far too much. It's in the atmosphere. Unfortunately, far too much carbon. So don't see that as a magical idea, because biomass, it's what the plants, that's what the plants do. They pump the CO2 out of the atmosphere, and they focus it in a solid form, and which is usable. So we'll be using technological means which will enable us to capture the CO2 in the air, and associated with the hydrogen produced by electrolysis, we can have these SAFs. So thanks to these figures on the slide, we won't go into the detail, but there's a first overview, and I'll focus on France from here on in, because we're going to be talking about the feasibility for our country to decarbonize aviation. Why not talk about other countries? Because studies need to be carried out with the figures in the different countries. The capacity to produce electricity changes from one country to the next. The amount of biomass changes from one country to the next. So we'll focus on France. This is one aspect of what is at stake for a company such as France-KLM, a big group like that. So I said you need biomass and you need electricity. How much? And the true question is, therefore, do we have sufficient amounts of biomass and electricity to solve this problem? So we'll look at 2 timescales, 2035, a midterm, and 2050, long term. First question, the quantity of biomass available. It's a complicated topic and which is probably quite versatile. It depends how it's looked at from a political point of view and what decisions are made politically. Because of this competition for usage, there are political usages which may translate into rules. So you say this sector can't have access to biomass if you're in competition with the food sector. We've said that providing food is a priority. There's a lot of debate, and this will get ever further with regard to protecting biodiversity and so on. So when we look at the quantities of biomass available, a lot of international agencies, they count on the doubling of the energy available between now and 2050. But a lot of technical studies say it's going to remain stable because you have the erosion of the grounds, climate change, and so on. So a technical uncertainty with regard to such a major factor. But the biggest uncertainty is political with the competitions for use. So the 6 million tons of biomass available for the airline sector, for the air sector that you see here, is really very uncertain, because it's an estimate which we have to take into account the political decisions which will be made. So how much biomass could be taken by the air industry, and it's economic, maybe a debate, and if you pay more, maybe you'll get more, but there's a social aspect. There's also biomass, fuel heating, wood for heating, and so on. So we looked at work done by the European Commission, but it's quite conventional. 10% of the energy available in our country could be used by the air industry, and that's 10 million. But biomass is fantastic because it brings carbon and hydrogen. But the 6 million ton for us is a maximum. That's how we see it. Once we've provided this maximum amount of biomass available, and after its calculations with the figures on the previous slide, to see how much electricity needs to be produced. So biomass, if we want it to double, it is what it is, and the soil is soil. But with regard to the quantity of electricity we can invest, so we arrive at these two figures that we're going to be commenting now on because they have major consequences. It's a decarbonization of the air sector for France, and given the mandates given by Europe, there needs to be some 20 terawatt-hours, and we need to arrive at 170 terawatt-hours. So what does that represent? It needs to be compared to something. Today, France produces 555 terawatt-hours. In 2019, we were exporting 50 terawatt-hours. Between now and 2035, we're going to have this hypothesis. It's that we're going to retain. So now we're talking topics which are outside the aviation industry, but the energy needs to come from somewhere, and it's a key topic. It's one of the two key topics that we'll be talking about in this presentation. The first point, hypothesis, we retain the nuclear fleet at the level it is currently, and that we continue to develop wind farms, solar panels, solar farms. France has committed to already back in 2019, we were exporting 50 TWh. If we retain the nuclear fleet such as it is, and that we increase production of renewable energy, we arrive at, we can estimate that France will have some 100 terawatt hours available by 2035. We need 20 for the aviation. It's significant, but it would work. Some may say that is a lot, but when you look at the decarbonation of society and not just of the aviation industry, you can see that electrical production will need to increase significantly. So we say by 2, will it be plus 80%, plus 90, or plus 100%? We'll discover that with time, but that's the order of magnitude. And biomass can contribute to that, but you have maritime freight and road freight, etc. So you can see that with the energy trajectory scheduled by France, we'll have a sufficient amount of electricity, and that is important. And it might become one of the main points of attraction of France for investors. 2050 now. 2050 for the decade 2040 to 2050, we'll have to invest massively with regard to electricity generation. So there's one point which I haven't come to yet. We talk about electricity production. I've talked about TWH, but not all electricities are the same. The figures I'm giving are only if we have electricity which is very decarbonized, very, very decarbonized. The European mix with 300 grams of CO2 by kilowatt hours, that's excluded. Let's not even talk about the German mix. What would happen if we use the average Europe electricity? SAF would be producing more CO2 than fossil fuels, except that you've lost billions of euros meanwhile because you'll have invested in production plants. So the French mix, and that is a heritage that provides us with an opportunity with regard to this capacity to decarbonate and to be compatible with the production of SAF. So let's look at 2035 because we have a problem of rapidity of deployment. We need to invest very rapidly, but the countries where you can invest very rapidly are those where there's a sufficient amount of electricity available, and electricity at a very low carbon electricity, such as is the case in France, and is a situation which provides us with this opportunity. We've talked a lot about entrants, so you need the ingredients, is biomass. We've talked about that, electricity, we've talked about that, but now we need the chef, the plant which produces these fuels, so we won't go into the details here, but behind this table that you see on the left there, several realities. It's a very big plant, big refinery plant. That's what we're talking about. It will represent huge amounts from an investment point of view. So there's the economic factor again there. But what is important today is that the system really needs to be started up. Where's the risks? Of course, money is needed, investments, spaces need to be identified, areas. We'll need to find to talk with the local population and so on, and build these plants. But top right, what about these technologies? It's equivalent of refineries. Technological maturity is 100%. We know how to do that. With regard to the middle part there, it's more complicated. We have chemical reactors. There's an example here, which is what we call the Fischer-Tropsch reactor. It's invented by our German friends. It was during this Second World War, by Germany at any rate. But it's a technology which is some 60, 70 years. So it is matured, but it hasn't been rolled out to big scale yet. It's in that reactor that you can transform carbon and hydrogen into hydrocarbon chains. On the top here, you see we're not really industrially, we don't have control really yet, so we need to invest with regard to capturing CO2 in the environment. Those are new technologies. Electrolysis, generally speaking, is a major topic, and the optimization of these installations and plants. Why? Because the yield of the whole of this procedure and process needs to be 50-55% around there, and that is possible. The technological maturity, we can attain it, but there's a lot of work ahead, and we're not there yet. This figure of 50%, what is it? It's the relationship between the quantity of electricity that you need to put at the start and the electricity that you can use in order to have the planes to fly. That's ambitious, 50%, no doubt about it, and it will require a lot of technological progress and work. If that work is done, we can then assess and evaluate a potential cost at any rate of SAFs, and notably here of SAFs of the e-fuels at 2 euros per litre. Today, we're more at 0.5 euros per litre, so there's a factor of 4 between today's kerosene jet fuel and an SAF, which may be qualified of 2040 vintage. But we mustn't just compare the price of SAF tomorrow of the price of kerosene yesterday. That's not logical, clearly. So we also need to anticipate, and that's our analysis, that the fossil fuels will tend to go up, will increase with regard to the growing difficulties of extraction, plus the taxes which will be on them. So to simplify, it will be 4 times the cost of today. It could be at a factor 2 of the fossil fuel tomorrow. So I will conclude. I will conclude with this slide by reminding ourselves first that what the stakes are. So what the stakes are for aviation industry, these stakes and challenges are shared by the whole of society. It's not just one single industry, it's an issue, and this is just an example, the aviation industry. So we need to roll out initial industrial stage over the next decade. All the solutions which are not industrial by 2035 will not be ready for 2050. And that really needs to be looked at and explained to the population. We have a stake that we talk a lot about, but now it becomes a stake of rapidity. We've been looking at thinking, but now we really have to get on this curve, this steep curve ahead of us. This first 2035 milestone that needs to be followed by a rollout at a major scale, and that will have an impact on the industries of countries such as France, on the territory, on the commercial balance, because everything that you spend abroad today, you can spend it at home, and it will have an impact on sovereignty. So actions which are required in France, you need to secure the electricity production, so there's no SAF production without a public policy of energy production which is coherent. The second one, it's mastering critical technologies in France. So those are really where we need to move forward. It's energy and policies from an industrial point of view and from a government point of view, and of course we are not going to be the aviation industry is not going to be manufacturing solar panels and so on, of course, but we need to we need to talk to the governments, and they can hear all these expressions of needs, but they don't have customers, SAF producers. So there's a problem of the egg and the hen. If there's no major investment on the biomass systems and electrogen ones, there'll be no SAF. But if there's no industrialization of SAF, there's no needs for those resources. So we need to move away from this vicious circle, if you will. And the first thing to do is to have companies, groups like Air France-KLM, who express what their needs are, what they will be, and where they need to go, because you don't have the solution on your own, in your own hands. You need to talk to the policymakers, and to the industry. So I'll conclude with that. I thank you. So I'll just put this slide up as I leave you to remind ourselves that the major idea that we've talked about, Antoine and myself, it's the circular economy of carbon. Thank you for your attention, ladies and gentlemen. Thank you very much, Antoine Laborde and Mr. Iracane. Please stay with us up here on stage, and we'll have a Q&A session. So please raise your hand if you have a question or an observation, and please introduce yourselves before your question. Thank you. No questions, it would appear. Here we go. So, a microphone. Thierry Dubois. A question for Mr. Laborde. You talked about the major gap that exists, the price between classical fuels, kerosene, and SAFs today. I think you said between 4 and 8 times. Could you develop a bit further and say what are the cheapest, what are the most expensive? Where does this gap come from? The fact that it's times 4, times 8. Where does that difference? How can that be explained? Well, the totality practically of SAF produced today throughout the world is a technology called FA. And it's from used oils, and it's a technology which is done in the most industrial manner today. So that's where we have the cost, the lowest cost, which are available, and you may have over cost today with regard to kerosene, which are around 2,000, 2,500 euros per ton of SAF. So that is really the category, with the lowest category, if you will. And then when you go into more details or the technologies, Daniel Iracane talked about them with biomass coupled with hydrogen, or indeed made from hydrogen directly. When the capture of CO2, we may be looking at prices which may be 6,000, 7,000 euros per ton. So today, it's not easy to provide those prices in a precise manner because for the EU fuels, everything will depend on the cost of electricity. So a cost of a kilowatt, what is it? That depends. That will have a major impact on the final cost and price. And today we're just talking about production plants which are pre-industrial. We haven't attained this level of maturity, the technical maturity, to attain the 2 euros per litre that Mr. Iracane was talking about just now. The second component, it's in some countries they have implemented aid subsidies for production. We're talking here about the United States with lira, which can decrease drastically the price of SAF, or in the Netherlands too. The Netherlands with HB, which are a pool with work with road fuel, fuel for cars. So they have a price of SAF which is very low, much lower for the airline companies. So the technology of production, which are not yet at maturity, and what subsidies exist, what aids exist, country per country, to in favor of a cost of purchase which is as acceptable as possible for the airlines. Gérard Fetter for France Info. We talked about costs. You've talked about costs, the cost of SAF, which is from sales, Total or elsewhere. And there's also the manufacturing cost. Does that mean that Air France-KLM or other airline companies may be investing in the production of SAF? Well, that is a very good question. A very good question. Today, the airlines, they just coming out of the COVID crisis, which was obviously substantial, and they don't have the means to invest massively in production plants, where we'll be talking about several billion euros. Investment. So we believe that if there are investment opportunities, it will be quite limited in scope, but we can feel that what we can bring to the ecosystem, it's going to be really helping the production by committing to purchasing over the long term, to guarantee to producers of SAF, to say that we can tell them, if you invest, if you produce, we can guarantee that for 10, 15 years, we will be purchasing from you and use up your production. So that's our first lever as airlines, but things may change. But as of today, we don't see ourselves as direct producers of SAFs. So maybe to complete what you say, it's a true topic to find the ecosystem which can produce, because there are no major natural players with regard to this new industry that we're talking about. So the signals that the final, the end users send are going to be very important to bring to the fore. You might have joint ventures, consortiums. So for all the industrialists capable of implementing this type of production at this level, it's really a new industrial world that needs to be created.
Oui,
Jean-Pierre Wed, Energy Balance Association. Now, you've talked about how crucial it is to use the two basic resources, electricity and biomass. You also said from the biomass side, 10% is used, but it's a very approximate figure. Biomass is not what we thought it would be. There's a huge amount of demand for it in various sectors. So do you think you'll be able to look in that in more detail to properly establish where you can source this biomass, how much you need for wood, for energy and fuel? That's my first question. Second, we've had this panorama based on this. It's difficult. 50 euros per megawatt hour, that's the price you've got, but you not necessarily can keep that. But do you think France is well placed compared with other countries for producing SAFs? Well, I'm not playing on words, but it's not 10%, which is approximative. It's conventional, it's worse. So it's going very much in the line of your fear. At the end of the day, there'll be a public arbitration. There might be a debate to decide whether it's the market that will set the price or the state authorities. But because there's competition between economic sectors that have different weights, aircraft, maritime, for example, are they fighting with equal arms? But there's also pellets for heating your home. So there are concerns, and the concerns we have is that this can all generate question marks over a 10-year period. A political uncertainty can generate regulatory uncertainty. Now, if you're an investor and you've got several billion euros, this is something you need to think about. But if you have certain demands and you want to know that in 10 years, 15 years down the road, your investments are guaranteed, who knows? Now, we're not going further in this because the subject is not worth looking at. But the conventional side of things means that you cannot home in really on the statistics. In Europe, there's been a debate now about collecting forestry waste. It didn't go very far, that debate, but there's a tendency of raising objectives and drawing down means, resources, which isn't coherent. So first, we need to consolidate all our needs and see greater clarity, more consistency. Otherwise, we'll really get things wrong. Electricity-wise, it's crystal clear. France is a country where it will be attractive to produce SAFs. But before anybody asked the question, of course, we need to remedy matters that we had in winter 2022. And of course, this coming winter, but we won't decarbon unless we have better understanding of our electricity mix. But we are considerably decarboned. 30 grams of CO2 per kilowatt hour in France. You need to be about 20 to get a factor of 10 effect for CO2 emissions. And so the average in Europe at 300, Germany more than 400. So you can see that our neighboring countries are going to have to do much more to decarbon than we do. But we've got that behind us now. So, if we do what we have to do, then we should be an appealing country, attractive because of decarboned, available electricity that can be provided in a safe and secure fashion. Jean Guérin from Le Figaro newspaper. 2 questions for Air France. Why are you calling for the creation of a SAF production industry in France? Because you could buy this elsewhere, outside of France. And for kerosene, this is indeed what you do. So that's my first question. Second question, now, is there an apparatus that could be envisaged Europe-wide? Is it in the pipeline, such as we see in the US, or not at all, for putting together a SAF manufacturing industry? Now, in our company, we want to buy SAF wherever we use our aircraft. So we can do that around the world. Half of our fuel consumption is done here and in Amsterdam. So we've got bold objectives SAF-wise. Yes, we could contemplate transporting SAF to the other end of the world, Paris and Amsterdam. But we think from an environmental perspective and energy perspective, it's more meaningful to try and produce SAF as close to home as possible, close to its point of consumption. This airport here and Schiphol in the Netherlands. We also think that it's a genuine opportunity for European countries to source SAF, this emerging industry, to source SAF. We've seen this recently, thinking about energy independence, for example. These are weighty matters and can hit us hard. So it's an opportunity for an airline company, I would say, to see sustainable fuel that is secure in Europe and close to its point of consumption. That was your first question. And the second question, yes, there are European mechanisms. These mechanisms will emerge shortly. The SAF allowance, for example, which will help significantly reduce SAF costs, but only for inter-European travel. Now, we've talked about this. Obviously, that's only a fraction. Well, it's no small beer, but anyway, it's part of our total emissions. But so because of that, of course, it won't help us totally remedy this problem of the extra costs entailed by SAF. But this apparatus is being put together as we speak. There are also discussions, interministerial discussions, that are underway as we speak to try and understand what measures could be used to support the manufacturing of sustainable fuel, support for production investments, but also mechanisms which would make it possible to fix or predetermine SAF prices. So this is underway. Of course, the stakes are high to make sure that SAF ultimately in France isn't too expensive or not more expensive than SAF in the United States or elsewhere, so that we can have production, have a market which is competitive. Last question, please.
That's okay.
Yeah.
I'm Ten Kramer from Travel Media in the Netherlands. What I'm thinking about, you're the technicians and not necessarily the airline. We hear a lot of 2050 carbon neutral diminishments by 2030. This is midterm and long term. By 2050, most of us will be doing something else. From a technician point of view, I've heard a lot of if and when and but, and how realistic is that we actually get carbon neutral by 2050?
Okay.
Because I will be back in 2050.
Okay, so we put the emphasis on really two topics, and it's not the end of the story because I didn't address the financial aspect, the competition, the consistency between the regulation all across the world. So there is a tremendous amount of work for you. So, but we have focused on two necessary conditions. Do we have the input, and do we have the technology? So for the input, the answer is the biomass, even if it is with addition of hydrogen, will cover at most 20% of the need. So the majority of the SAF will be, at the end of the day, the synthetic kerosene. And in most of the literature, you will find that, okay, let us start with the biomass, and then we will invest in the kerosene. This is wrong. This is wrong. It's true that the synthetic kerosene will come later, perhaps. Not perhaps, sure, in terms of market. But it is more challenging, so you have to invest now. So one of the points on which I would like to put the emphasis is that we have to invest now. And when I say now, it's not within 10 years. In the coming years, let us say that in a country like France, we should be able in 2025 to take some decision in principle, saying, okay, we go collectively. Collectivity means the state, the industry, all the key players. We go in that direction all together. Is it possible to go to this point? In fact, we have still some uncertainty on the technology that prevent, in our view, to make big decisions on the field. So the roadmap, if we want to discuss in terms of roadmap, should be that we have to decrease the risk on the technology, and we know where the risks are. So it means a kind of development investment, which is not a tremendous amount of money. It's not research. It's not a matter of labs. It's a matter of industrial deployment. But we need to have mock-up, to have experimental facility. Look, for example, the direct air capture. There is technologies that has been implemented in Iceland. This is by a company in Switzerland. There is a company in Canada. Let us try to see what is possible. Let us ask in France, in the Netherlands, the public research organization to invest people in that field, and in order to control this technology and to be sure that we can say to the final decision maker, let us say again that you have billion in the end, is it time for you to jump? I would say we need to secure a little bit more the technology. It exists, but it's a matter of decreasing the risk before to jump. And then we have to go very fast in the deployment.